Hello, welcome to Brunei Math Club. In this video, we study block matrices. For example, if we have 4x4 matrix like this, we can split this into blocks, for example, like this. So this is one block, another block, another block, yet another block. So this matrix can be written as something like A11, A12, A21, A22, and each of these are matrix. Okay, let's start. What's nice about partitioning a matrix into blocks is that we can simplify some matrix operations by reducing it to smaller matrices. For example, consider this matrix product. We have this 4x4 matrix and this 4x2 matrix, and if we calculate this matrix product based on the definition, so calculate, first take the first row and first column, then we get this, and first row and the second column we get this, and second row and first column we get this, and so on. So as a result, we have this matrix, but let's calculate this in terms of block matrices. So for that, we split this first matrix into 4 blocks, and the second matrix into 4 blocks. So 1 block, 2 block, 3 blocks, and 4 blocks, and so on. And same for the second matrix. So this would be written as A11, A12, A21, A22. So A11 corresponds to this block, and so on, okay? And similarly, B11, B12, B21, and B22. And calculate this as if each of these blocks is a number, almost. So this becomes A11 times B11, A12 times B21, and A11 times B12 and A12 times B22. And same for this, A21, B11 plus A22 times B21, and A21 times B12 plus A22 times B22. So let's calculate each of these in turn. First, pick this part. A11, B11 plus A12, B21. So A11 is this. So 1, 0, 2, -1, and B11 is this. So -1 and 0 plus A12 is 2, 1, 0, 1, and B21 is this, so that's 1, 1. So it's easier to calculate matrix products with smaller matrices, and this becomes so -1 and -2 plus 2, that's 3, and 0, 1, that's 1. So we have 2 and -1. And we do the same for this, this, and this. Then we have this element becomes this, and this element becomes this, and this element becomes this. So let's put them together. So we have the resulting matrix. So the first one is 2, -1, 2, -1, and the second one is, what is it? This one, -1, 3, and 4, 0, and negative 3, 4. So that should be it. So compare this with with this one. So that's the same matrix. So whether you partition matrices into blocks or not, you get the same result for a matrix product. And the way you partition a matrix is not unique. So for example, in this example, you could partition a matrix, for example, that the second matrix into two blocks. For example, like this block and this block, or this block and this block. But of course, after partitioning, the form of the matrix should be compatible with the matrix product. For example, since we partition the first matrix into 4 blocks, it's a 2 by 2 block matrix. So the second matrix should contain 2 rows. Okay, so partitioning into this way doesn't work, but partitioning into this way can work. So in that case, let's say this block is C11, and this block is C1, C21. So in that case, we have A11, A12, A21, A22, and we have C11 and C21. So this for this block matrix, these block matrices, we can calculate the matrix product. So A11, C11 plus A12 times C21, and A21 times C11, and A22 C21. And you should try that, and you should get the same result as this. A particularly useful class of block matrices is that the block matrix consisting of column vectors. For example, if we have this 3 by 3 matrix, we may partition this into column vectors A1, A2, A3. So each of these column vectors correspond to these columns. For example, if we multiply this matrix by a column vector, let's say lambda 1, lambda 2, lambda 3, then we have A1, A2, A3 times lambda 1, lambda 2, lambda 3. So this is 1 by 3 matrix, and this is 3 by 1 matrix. So the result is A1, lambda 1, A2, lambda 2, A3, lambda 3. Well, usually we put the scalars first before the vectors. So usually we write like this: lambda 1, A1, lambda 2, A2, and lambda 3, A3. So by partitioning a matrix into column vectors, we can write the product between the matrix times a column vector like this. In this case, the matrix should be multiplied from the left. And next, consider multiplying this matrix A with a diagonal matrix: lambda 1, 0, 0, 0, lambda 2, 0, 0, 0, lambda 3. So this second matrix is a diagonal matrix. So this is A1, A2, A3, and the diagonal matrix. And this becomes, let's see, so this is just A1 times lambda 1. Let's put the scalar first. lambda 1, A1. And the second column is lambda 2, A2, and lambda 3, A3. So this apparently looks like a 1 by 3 matrix consisting of these elements, but each element here is a column vector. So if we put back the elements of these column vectors explicitly, this becomes lambda 1, A1, 1, lambda 1, A2, 1, lambda 1, A3, 1, and so on. So each column is multiplied by a separate constant. That's what happens if you multiply a matrix by a diagonal matrix from the right. So each diagonal appears in order. Okay, that's all for this video. See you later. Bye. Thanks for watching. If you like this video, please hit the like button and subscribe to this channel. See you next time. Bye.